Het is de vierde en laatste dag van de International Broadcasting Convention, IBC. We zijn nog steeds aan het rondneuzen op de Future Zone, waar de prototypes van toekomstige technologieën ons begroeten. Het heden is leuk, maar vooruitkijken is misschien nog wel veel leuker. Terwijl de aandacht tegenwoordig steeds meer uitgaat naar overtreffende trappen van video zoals 8K, is er een iets meer vergeten tak: 3D. 5 jaar geleden was het een hele hype vanwege de film Avatar. Maar 3D kwam nooit echt van de grond. Wellicht de onhandige en vooral ook dure brillen die bij de 3D-televisie aangeschaft moesten worden. Daarom gaat de aandacht nu uit naar andere manieren om 3D-televisie te kunnen kijken. So I'm standing here with Michael Schäffner. Yeah. Michael, can you tell me a little bit more about yourself and what you do?
Yeah, sure. So I'm a PhD student at the Integrated Systems Laboratory at ETH Zurich. And my PhD project is together with Disney Research. Here, what we see, our booth in the back. My topic is microelectronics for video processing. And what we are presenting here is the outcome of this project, which is automatic multiview conversion.
So that's the box that we're looking at right there in front of the television.
Exactly. So what you see there in the back is this screen, which is an autostereoscopic multi-view display, which is able to project several views of the same scene into different directions, and this allows you to perceive 3D without glasses. The issue with these displays is that you usually don't have the content for them, because they require 8 views or even more in the future. And what you usually just have is stereoscopic content, because all the movies are either converted or shot in stereoscopic 3D. So what this magic box there does, it converts this standard stereoscopic 3D content into content appropriate for such screens in real time.
So you can just take any Blu-ray and display it in 3D?
Exactly. So it takes in the left and the right view, analyzes the content, and calculates the transformations for all the intermediate views and renders them and interleaves them such that they can be displayed on such a screen.
Yeah, and with normal 3D you usually have to be in front of the screen. Does this also mean that there's multiple viewing angles for it?
Yes, so you still have some geometric confinement in the sense that you need to be at the right distance from the display, but there are repeating viewing zones where you can actually perceive 3D without glasses. So this display would more or less allow about 20 users to perceive 3D and watch the content together.
Okay, and can you tell me what the difference is between technology like this and, say, a Nintendo 3DS?
Yes, so a Nintendo 3DS, as far as I know, has a parallax barrier-based display, which means that it only projects 2 views, like standard stereoscopic content, and then if you are at the right position, you perceive 2 different images with your eyes. The difference to this kind of display is that it projects more views. It can project 8, 9 or whatever your resolution of the display allows, and this also allows you to give a sense of motion parallax, because you can slightly change your viewing position because you have more views of the same scene.
I see, but we're still looking at a big box right now. Is this something that could eventually be integrated into a television itself?
Exactly. So the box is a hardware system, but it's that big because it's a prototype. There's an FPGA in it. There is part already on an ASIC, an integrated circuit. But eventually you could integrate all this together onto a single chip and put it into the displays, where it has to be small and power efficient.
Okay, we'll see what happens with the system. Thank you.
You're welcome.